Hello Internet, my name is Quinn. This is Blondihacks. I'm starting a new project today. I'm going to build a DC generator. I've had the kit for this thing in my drawer for a really long time, and it's finally bubbled its way to the top of the project queue. So let's go. Here's what I'm going to be building. It's a Dynamo or DC generator. It's a little guy, but it'll do 10 to 12 volts at 10 watts at 2.5 amps. So that's enough juice to do some pretty interesting things. You can charge your phone, or you could even run some high efficiency room lighting. This is a kit from PM Research. It comes with a cast iron base casting, a couple of aluminum end bell castings. Also comes with the permanent magnets and the rotor itself, which is pre-wound for us. Then there's some stock in here for various bits and bobs, and all the hardware is included. This is a really nice little kit if you're interested in getting started with machining castings in your hobby shop. If you've never done this and you want to kind of get your feet wet, this could be a great way to start. Speaking of starting, I'm going to start with the cast iron base casting. As with most castings, I'm going to start by fettling it, which is a very British way of saying grinding off all of the mold lines and other imperfections caused by the sand casting process. These castings from PM Research, in my experience, are generally very, very good. They've actually ground off some of the debris, as you can see there. Sometimes there are risers or other big chunks left over that you have to take off, but not so here. A little bit of work with the Dremel was all it took. Now let's make some chips. I've got emery paper on my vice jaws to protect them from the hard outer shell of the casting, and also it helps take up the imperfections in the casting and give you a better grip. I'm going to machine the bottom of the base, or the foot if you like, of it, and that's going to be my first reference surface. Machining castings always starts with creating a reference surface, and this is always a bit of a guessing game. You have to kind of pick something that you think you can get level or straight or square to the casting, but you don't have any references yet because all of the casting surfaces are all cattywampus. In this case, I'm starting with the base foot because I think I can relatively easily get this straight and flat and level in my mill, and then we can go from there. After eyeballing it with the square, I've got the dial indicator on it, and I'm looking to find a position where the drop-off is the same at both sides of the foot. This foot has draft angle on it, so it's high in the middle, and it drops off to both sides. So if the drop-off at each side is the same distance, then that foot should be essentially level in the vise. I'm relying on the ends of the casting to hold it square in the other axis, which is reasonable in this case because there's no draft angle on the ends of those bores, and, well, reasonably accurate at this stage is really the best you can do with a casting. There's always going to be a little bit of educated guessing and a little bit of luck, frankly, to get all of the features well aligned with cast surfaces, because it depends very much on the quality of the casting, how straight things are, whether the casting has any twist in it, and so on. And furthermore, any error that you might be trying to eliminate might be smaller than the noise floor of the error that's in the surface finish of the casting. It's not unusual for castings to have, say, 10 or 15 thousandths of roughness in the surface. So if you're trying to get it straighter than that, well, you're just guessing anyway. Now I can come in and touch off on the high spot and start making this surface flat. My goal with this surface is to remove as little material as possible until the surface just cleans up all the way across. There is a minimum height restriction that I'm trying to avoid violating between the center of the bore and the underside of this foot. That's really the only dimension we have here, is just trying to stay above that minimum, which we should be able to do if we take the least amount of material off of this foot that we can. This is the other reason you want to try and get it level, because if the casting is more crooked, you have to remove more material to get it straight. After a few passes, I did have one little edge here that didn't quite clean up, but that's quite a deep mark, and to remove enough material for that to clean up, I'd have to go way too deep on the surface, I think. So you got to call it at some point. Again, so I don't violate that minimum height requirement between the bore and this surface. It's always quite satisfying to get that first reference surface on a casting though, because now it will sit nice and flat on a machined surface. At least if you did your job right, it will. And that's always really, really pleasing. I've come in now with my fixture plate in the vise, and I've got a piece of scrap material that's nice and parallel top and bottom that's going to be sacrificial, and I'm going to set the piece up like so to drill the bolt pattern in the feet. In my experience, after you've got your first reference surface, it's really helpful to get some holes in the casting somewhere, because odds are you're going to need some way to fixture this thing in the near future in other creative ways. And if you've got holes in it, well, now you've got options. And we're going to have to do these holes eventually anyway, so we might as well do them now. I'm using a drill that is the radius of the spot face that the holes are going to have around them. And that will allow me to visually and by feel sense when the bolt pattern is nicely spaced on the foot. This is, again, aesthetic, but the centers of the bolts need to match as much as possible the bolt pattern specified in the drawing. So this is very much a trial and error sort of thing. You have to go back and forth trying two different holes that are the correct distance apart at different positions on the casting until they both seem like they're centered on that axis, and they're both going to look nice near their respective corners of the casting. Then you do the same thing on the other side, making sure that those two holes, when positioned the right distance apart, look good. And then, of course, the two pairs of holes need to be the correct separation across the casting, and you're going to need to straighten the casting out a little bit, and you're going to have to shuffle it around and go back and forth a lot until you land in a position where the DRO says all four holes are in aesthetically pleasing and reasonable locations. I also double checked that the little boss on top is going to be at 0, 0 on my hole pattern, and that looks pretty good. That little boss is for a lifting eye detail that's coming later. Now I can come in and do the spot faces. The spot face happens to be the size of a long reach end mill that I have, which is immensely convenient. That was a lucky break. So I can use this end mill to reach down there and do these spot faces. If I didn't have this crazy long end mill, I might have to make a tool for this, maybe on the D-bit grinder or something like that, but it's nice to get lucky once in a while. Those spot faces go where the DRO tells me to put them according to our bolt pattern that we figured out in the previous tedium. There's no science to the depth of these spot faces. I just go a little bit at a time until I have a nice clean looking flat spot basically all the way around the hole. Once I have a flat spot, then I can come back in with the center drill and center drill the center of each of those spot faces so that my drill will go right down the middle of them. On a little casting like this, the spot faces might extend over the edge of the casting a little bit. That's kind of unavoidable. With castings this small, they're never quite perfect, and there's never exactly as much material in every place as the drawing says there should be, so your bolt holes might not look perfectly, aesthetically, pleasingly centered on the corners, but you gotta do the best you can with these things, and they're not going to be perfect. Each of those wells get drilled until aluminum is struck, then you know you're through, and on to the next one. While I'm here, I might as well do this top little boss here, which is going to be parallel to the bottom. There's nothing crucial. This is for a lifting bolt, like a tiny little eye bolt, that if this were a full-size Dynamo would be for lifting the thing with a crane. It's just a little detail piece, but it might be useful as a reference or a fixturing thing later, so I might as well do it since we're all set up. So I milled that flat, then center drilled and drilled through. We're done with this setup, and now we've got a reference surface and a bunch of bolt holes and lots of fixturing options. So now we can get on to the real meat of this piece, which is the bore. Hopefully all these holes and surfaces will come in handy for that setup. One of the trickier jobs when machining a casting is facing two surfaces down so that the resulting distance between those surfaces is correct according to the drawing, and that the amount of material that you remove is roughly equidistant on both sides of the casting so that the features remain centered on the casting when you're done. I have found the best way to do this is usually casting layout. So I've got the piece clamped to an angle plate on my surface plate, and I'm setting up a gauge pin in the bolt holes, and I'm going back and forth and tapping the piece until those two bolt holes are at the same height. Once I can put the gauge pin in both sides and the height gauge reads on the pin at each side, then I know the casting is level with respect to my bolt holes. And that's going to be my reference for laying out the bore surfaces at each end. Next, I put a gauge pin in the hole that we drilled for the lifting eye. This is going to be my center reference for this axis. We know that that lifting eye is reasonably well centered on the casting and centered on the bolt pattern in the foot, so this should be as good a reference as any. I'm going to set the height gauge on that surface of that pin. Then I'm going to take the reading on the height gauge and subtract the radius of that pin, lower the height gauge by that amount, and my height gauge is now on center on this casting. So now I can lower the height gauge by half the amount of the length of this bore, and I'm going to scribe a line. And that's going to be the lower surface of this bore, or one end of the bore should end up on this layout line. You may not be able to see these layout lines on camera, but I am scribing them with the carbide tip on the height gauge, and they do show up quite well in person. Next, I add the overall length of the bore to that value. In other words, go up the same amount in the other direction from my lifting eye measurement and scribe another line. And that will be the other end of this bore. So those two lines should be equidistant from the center of the lifting eye, and they should be the correct distance apart, which I can sanity check with my caliper. And that looks correct. So those layout lines are going to ensure that when we machine these surfaces down, they're going to end up centered on the casting and the correct distance apart. Now, these layout lines are only going to be guidelines for the first cut, because layout lines are never as accurate as cutting and measuring, as you'll see. To set this up on the lathe to cut the bore, my first thought was to bolt the casting to either an angle plate or possibly a 1-2-3 block, then bolt that block to the face plate and spin it up like so. That will guarantee that the bore is square to the foot, which is important, and it'll be a very secure setup. But faceplate setups are a lot of work, so I thought, well, why don't I try my 4-jaw? Because it looks like, actually, this fits really nicely in my 4-jaw. And if I line up the base of the foot on one of the 4-jaw jaws, then that should help keep it square. Now the other jaw is landing right on my lifting eye boss, which is a little strange, but we'll see how that goes. I set it up in the 4-jaw, and I even started dialing it in a little bit, but as the jaws got tighter, I could see that the jaw that was sitting on that machined boss for the lifting eye was kind of canted at a bit of an angle, like it was stressed from that position. It wasn't going to be a secure grip, and probably not great for the jaw either, so I decided to redo this setup, pulling it out a little bit, and I'm going to put some copper as well on the surfaces. The copper protects machined surfaces from the jaw and gives you a better grip on rough cast surfaces, and the copper also gives you a little bit of movement in the piece so you can tap it around easier. If the jaws are clamped tight onto the cast iron directly, it's more difficult to tap the piece in straight. I'm going to dial it in now. Conveniently, there's enough of the casting sticking out past the foot that I can get my indicator in there. Dialing in a casting is always a little bit of a gamble or educated guessing kind of game, because you're trying to dial in a piece, again, say better than 5/1000ths on concentricity, but the surface texture of the part has probably 10 or 15 thousandths of variation in it. So there's only so much of that you can do. So at some point you're kind of making your best guess and you do the best you can. I got it within about 10 thousandths here. Next, I want to try and get the outer surface of the casting straight, because I want to make sure that my bore is going straight through the casting and is going to come out centered on both ends of the casting. Again, the variation in the surface is usually more than the accuracy you're trying to achieve, but again, just do the best you can. I'm checking the two axes opposite the foot, because in principle, the jaw on the 4-jaw should be holding the piece square on that axis, so my bore should end up square to the foot. So this is really just sort of a side-to-side straightening, if you will, of the bore on that casting. These PM Research cast iron castings, in my experience, are all really quite good. The surface finish on them for cast iron is quite good, so you can usually get them straight and dialed in and so on to within 5 or 10 thousandths if you take your time and you kind of mentally average the motion of the needle as it vibrates. You can kind of see when you're within 5 or 10 thousandths, which I think I am here. So I'm pretty happy with that. But of course, that straightening action messes up the concentricity. So you got to go back and fix the concentricity again, dial it in this way. Then after that, you got to go back and do the straightening again. And you just got to go back and forth until concentricity and straightness are both where you want them. This is tedious, but there's no getting around it. When you have multiple constraints in a setup, you just got to go back and forth until both are right. After all the dial indicating, just spin it up and check it with your old eye chronometer. The eye is actually quite good at detecting concentricity issues in a spinning part, but the trick is to get your head down low behind the tailstock and look straight on at the end, because your eye is not good at distinguishing between planar runout and axial runout if you're looking at the surface at, say, a 3/4 angle. So you want to get down and look at it from the end. And remember that this bore alignment on the casting is primarily an aesthetics issue. And aesthetic is a fancy way of saying looks good to the eye. So if it looks good to your eye when it's spinning up, then it's probably going to look good when the bore is finished. Now finally, after a lot of setup time, I can get to making some chips. So we're facing down one end of this bore, And remember those layout lines that we did on the surface plate? That's the goal for this facing operation. We're not measuring anything, we're just machining down to that layout line. The math on the surface plate told us that if one surface is on this layout line, then when we machine the overall part down to the correct length, the other surface will end up on the other layout line, and both surfaces will be roughly centered. Now, the centering of the surfaces on the casting is less important than the distance between them. The distance between them is an actual mechanical function of the machine that we're building, whereas the centering is aesthetic. So that's why the layout lines are used for centering, but we're going to be measuring to get the length. Now, importantly, I go in with the boring bar and do the bore without touching anything else in the setup. That will guarantee that the surface that we faced on the end is going to be extremely square to the surface of the bore, because the lathe slides are ensuring that for us as long as we don't touch the part in the chuck between these two operations. Maximum squareness on the lathe is always achieved by doing the two surfaces in a single setup. A question I get asked a lot when setting up a casting like this is, why don't you just indicate on the bore in the center of the casting? You actually shouldn't do that, because the bore on the center of a casting like that is done with a sand core, and those sand cores are very frequently crooked, frequently not very round, and the foundry doesn't make any special effort to make them accurate because generally they don't need to be. You're going to be machining the whole thing away, and they don't expect you to use it for setup, so they don't take as much care necessarily with those cores. So you always want to indicate on the casting that will still be there when your machining is done, because that's what you're going to see relative to the machined features when you're done. After a few passes with the boring bar, I start checking. I should be getting close now. I'm checking with the telescoping bore gauge. I like to check two different measurements 90 degrees apart on the bore to make sure things are staying round. And it's good to check at different depths as well to make sure you're not getting any taper. Or if you are getting taper, at least you know about it and you can adjust for it in the final dimension that you're aiming for. Things are looking good though, so this should be my final finishing cut. On the final pass, once the boring bar is all the way through, I stop the lathe, move the boring bar clear, and pull it out. Boring bars always have some deflection in them, so if you drag that boring bar back across the surface, even without moving the cross slide, you're going to cut a little spiral scratch in it on the way out, and you don't want to do that. So that's my final measurement right there. I'm about 1/1000th under. I check the deep end of the bore as well to make sure I've got no taper in there. I don't have any taper, but also about 1/1000 under. I'm going to stop here though, because trying to do one more cut and open that up by 1/1000th is a risky move. I'm likely to overcut, or even worse, I'm likely to bork up the surface finish, because taking really light cuts with a carbide insert boring bar does tend to screw up the surface on things. They do tend to chatter when trying to take really light cuts. So I'm better off leaving it 1/1000 under, and if that undersize is too much, then I can always hone it out later if I need to. I can remove the part now because I need to flip it around and face down the other side of the bore. I'm going to flip it and put it back in the chuck in such a way that the bottom surface of the foot is on the same four-jaw chuck jaw as it was before, because that's been holding the foot square to my bore in principle. And then I can get it back in, and I'm going to dial it in again. Now, dialing in the bore at this point is kind of a waste of time because we're actually just going to be facing the end anyway. What does matter, however, is that the end that we're facing needs to be as square as possible to the bore. So to that end, I did a bit of tapping in, and I've aligned the bore with the axis of the lathe to within a few tenths, as you can see. This will ensure that the cut is as square as we can get it. However, it's never going to be as good as doing the two surfaces in the same setup like we did on the other end, but we can get close. When I'm doing a casting like this, I will actually mark the end that was done in the same setup as the bore with a G or something for good, and that tells me that if I need to mount this casting to something else where squareness is super important, like say when mounting a piston cylinder casting onto the frame of an engine, I'll mount the good end to the frame where squareness matters, and then put the cylinder head on the other end where squareness is less important. Once that surface is cleaned up, now I can remove the casting again, or rather now I have to remove the casting again and measure it and see how much farther I have to go. Remember, on this end, I'm not machining down to the layout lines, I'm machining to the micrometer because length is more important than centering on the casting. I'm checking in a few places as well because I want to know how parallel I am to the other face, and it seems like I was starting to get a little bit out of parallel. I had what seemed like a couple thou out of parallel between these two surfaces. So I thought I'd change my setup a little bit once I put it back in. I'm going to reference the good end that we did in the same setup against some parallels that are up against the back of the chuck. and that will hopefully ensure that the facing cut we do here will be parallel to the other end. I'm going to tap that in so that hopefully the chuck jaws on the rough casting are not over constraining that and causing it to deviate from square as I tighten down on these chuck jaws. The copper also really helps with that to make sure that the chuck jaws aren't fighting the squareness at the back of the chuck. A quick check shows that I'm within half a thou of being square to the lathe on this front surface, so it may be that my parallelism issue was less than I feared. I also double checked that my bore is straight, of course, and once again we're back within a few tenths of straight there. So now I can finish machining this down. And again, I'm not machining to the layout lines, I'm just machining to the amount that I measured that I needed to remove when I checked it with the micrometer. And of course you will notice it is not running concentrically. Don't panic, I did not bother dialing it in this time because all that would do is create an additional constraint that isn't helpful. The more constraints you have on a setup, the more difficult that setup is to get right and the longer it takes. So I'm already trying to get it to where the back face is square to the chuck and the bore is perfectly straight with the axis of the lathe. If I'm also trying to get that bore concentric with the lathe, now that's 3 constraints and I'm going to have to go back and forth chasing my tail on all 3 of those constraints trying to get them all, and it's going to take forever and may not even be possible. So eliminate any constraints that aren't necessary for your setup, and for just facing the end, concentricity doesn't matter. I'm machining by the numbers on the DRO to get the length right, but as a sanity check, when I think I'm close, I can fish a parallel in up against the far surface and check that with the depth mic. It never hurts to double check that you are where you think you are after several cuts. If you aren't, well, better check something in your setup or your math or elsewhere. I have saved myself a lot of grief by constantly double checking cuts with different approaches, different measuring tools, and measuring different ways, and you can catch a lot of errors that way. Okay, that should be it. Survey says, let's see how we did. The overall length of the bore measured right on the money. Very happy with that. The straightness of the bore is good. It's centered on one end very well. The first end I did. The other end is a little bit crooked. You can see the castings just a scooch thicker at the top, but not enough that I think you'll notice. And otherwise, all the dimensions look good. So I'm pretty happy with that. But before I get too proud of myself, let's do some inspection on the surface plate on one relationship that's really important. The bore needs to be really square to the foot so that the rotor is sitting horizontal and the belt pulley is then sitting vertical. To check that, I'm finding the low spot of the curve at one end, and then I zero my dial indicator on that point. Then I move the needle to the other end, and I find the low spot of the curve at that end, and I check what the value is. And well, the news is not good. That is off by a good 20 thousandths. So that bore is quite crooked in there. That's disappointing. What went wrong here? Well, after some soul searching, I think I know. This 4-jaw chuck setup was not a good idea. I was counting on this chuck jaw registering on the bottom of the foot to hold everything square on that bore. And this is, remember, the dimension where it was crooked was aligning with that foot. However, what I didn't account for is that the jaw on the other side that's up against the rough casting is over constraining that and probably preventing the chuck jaw on the other side from holding the piece square. The bottom line is that we really can't rely on chuck jaws to hold things square on their own, especially when the surfaces on opposite jaws are not parallel to each other, as they are not in this case. And especially when it's a cheap import chuck with the jaws that are pretty loosey-goosey at the end of the day. They're not good square references. What I really should have done is the faceplate setup that I was too lazy to do at the start of the show. Lesson learned. However, the good news is I think this is fixable. I have more than 20 thousandths of extra material on the bottom of this foot, so I can redo the cut on the bottom of the foot and make it square to the bore. If I mount this on a mandrel to reference that bore and recut the foot, it'll cut that foot at an angle that will cancel out that error. I sketched myself up a mandrel that will hold that casting and allow me to put the other end in a 5C collet. I got a piece of scrap out of the bin, checked it up in the lathe, center drilled it, got some tail support in there, and let's shred up some aluminum. It's kind of a complex mandrel because there's a diameter in the middle that holds the casting, then there's a thread at one end for a nut to tighten down on the casting, then behind the casting there needs to be a large shoulder to clamp against, but then behind that shoulder there needs to be a smaller section because the shoulder that I need is larger than my largest 5C collet. The diameter of this middle section is the crucial one, This needs to be an extremely close fit on the casting. Any error here will probably defeat my efforts to correct the foot angle on this casting. And that is so very close. Like, you could probably tap that on, but you can see it's kind of cutting aluminum as I push it on. So it really needs to come a little bit smaller, but I don't want to risk taking another cut. So I'm going to use emery paper, begrudgingly. Don't like using emery paper on aluminum. It works fine. It removes the material, but it dulls up the surface and takes away that really nice fresh cut that you get with aluminum, which matters exactly 0 for this mandrel, but just makes me sad. However, a few seconds with the emery, and now that is the fit I wanted. That's about as tight as you could possibly make it and still be able to physically slide it on without a hammer. That's what I'm looking for. The more accurate that fit is, the more accurate this mandrel correction procedure will be. Finally, I come back in with a grooving tool to face the back of the shoulder and do a little bit of an undercut at the base of it. This will ensure that the casting clamps nice and square up against the back of this mandrel. You can't clamp against something like a collet block on a mandrel. You have to have a hard shoulder that's part of the mandrel. Otherwise, when you tighten the nut, you're just going to pull the mandrel out of whatever fixture it's in. That seats on there really beautifully. Now I can turn down a little section at the end all the way down to, I'm going to go 3/8/16 on this thread because that's the thread on my mill clamping hardware. And it never hurts to use the same threads on as much stuff as you can. That comes in commonly very handy. In this case, it allows me to, if nothing else, use the nice shouldered nuts in my mill clamping hardware as the clamping nut for this mandrel. And I'll face the end of that entirely for vanity. It matters not. Finally, I need to turn down a section behind the clamping shoulder that will fit into my largest 5C collet. I'm doing this with the grooving tool, which is kind of a lot of work, but it means that all of this is done in one setup and it will all be nice and concentric. And now I can part it off. You might be asking yourself, hey Quinn, why didn't you cut the thread on the end of that before parting it off? Wouldn't that be easier? Well, you see, there's actually a very complex and intricate subtlety here to the reason that I did it this way, and that's because shut up, that's why. I didn't have quite enough reach on that parting blade to get all the way through, and I was in danger of hitting the chuck jaws, so I didn't want to push my luck on that. So I finished that up with the hacksaw. Then definitely intentionally and definitely not because I forgot, I then put it back in the lathe and cut the thread on the end with the tailstock die holder. I said shut up, that's why. Don't make me point at the sign. If I did my job right, that casting will now slide on there up against the shoulder, and the mandrel area will be a little bit shorter than the casting so that I can put this handy fender washer I found that happens to be the exact right size, and that'll tighten down there, and that gap in there ensures that I get a clamping action on the mandrel. That is looking good. Over to the collet block then, and let's get this thing to pay for its lunch. That mandrel slides in there, and I can clamp that down. It was super handy that I found a fender washer the exact size to clamp on the end of this casting, although the washer is a little bit on the thin side, and it is going to tend to deflect, so I'm not going to be able to tighten this nut down very, very hard. If I needed to do heavy cuts or something on this setup, then I'd probably have to turn a steel disc that was going to be much sturdier against clamping force on that nut. I need to get that foot square on the y-axis. The y-axis is correct. We don't want to alter that angle. I'll get it in the ballpark with my little tilt box. This is a digital level. These things are great for little setups like this. They're not quite accurate enough for full-on machining setups, but I can get it in the ballpark, tighten it down, and then indicate it in the rest of the way. Because this is kind of a short surface that I'm indicating on, I've got the tenths indicator out, the highest resolution indicator. The shorter a surface is, the more difficult it is to detect a given amount of error in that surface. It's kind of the opposite of cosine error, if you like. So this is where a really high resolution indicator comes in handy, but boy, these things are jumpy. Little imperfections in the surface grain of the material can cause the needle to jump around, and they can be a little bit crazy making. But I got it straight to within a couple of tenths. Now that looks like a lot of needle movement probably on camera, but again, on this indicator, that's only a couple of tenths of error. That's certainly good enough for this axis. If my fixture is working the way I think it will now, if I put in my half-thou indicator, which is necessary to see this range of error, then on this axis I should see the 20 thousandths of error that I saw on the surface plate. And indeed I do. That is pretty much exactly the error I see there. So that is good. That means that my mandrel is set up correctly to, in principle, correct the error that we saw on the surface plate. I blued it up so I can see my progress and also to show you the angle that we're correcting, and I can start making cuts. I touched off on the high side and took a really light cut, so you can kind of see what's going to happen here. You can see that the cut is narrower than the end mill, and I don't know if you can tell on camera, but the Sharpie actually fades out into the cast iron. So you can see the angle of the surface underneath the cutter there, which is pretty cool. Here again, you can see how the Sharpie mark extends under the cutter. We're actually cutting half the width of the cutter, and that's the angle of the surface that we're correcting. So I took really light cuts, both because I want to remove as little as possible to correct this error, and also because my setup is not super strong, again, because of Mr. Fender Washer there. Once I've done a full pass at that height that removed the last of the Sharpie at the low end, that error should now in principle be corrected. Let's get it off of here and take it back over to the surface plate and put our indicator where our mouth is. Once again, find the low spot at one end, zero the indicator there, then move down to the other end and find the low spot once again, and survey says 2.5 thousandths. So good news and bad news. Good news, we removed an order of magnitude of that error. We went from 20-something thousandths down to 2.5 thou. That's pretty darn good. Bad news is, honestly, it should have been a little better than that. If that setup was correct in principle, it should have removed all of the error and that surface should be right on. There's no real reason that this shouldn't be, frankly, perfect now, or within a couple of tenths at least. There's going to be some error in the collet or whatever, but that should be better than that. Since I still have it set up in the mill, I went and checked the mandrel. And yeah, sure enough, there's my 2.5 thou of angle in that mandrel right there. That's why that cut didn't go as perfectly as it should have. So, well, I thought I've got it all set up again. I might as well straighten out that mandrel. I got it perfectly straight. And let's just do one more cut and take the rest of that error out. So once again, I double checked before making the cut that I should be able to see my error. And I don't. This time, when I pan across, that needle shows a perfectly flat surface. Now it's jumping around a little bit because that's a tenths indicator which can detect the tool marks, but that surface is flat and it shouldn't be. So I took the piece off and I checked the mandrel again, and the mandrel is crooked again. What I believe is happening is that the tapping in stage to straighten the casting on the y-axis is causing the mandrel to get a little bit crooked on the end. The tapping is causing the mandrel to either get crooked in the collet or it's causing the collet block to get a little crooked in the vise. At this point, I could try additional steps like putting a machinist jack under the threaded end of the mandrel to keep it level while I tap in the casting, something like that. Take some corrective steps to keep the mandrel from getting crooked. But at this point, I'm down to, as I said, 2.5 thou over 1.5 inches of error. That's frankly, I think, perfectly acceptable. And redoing that setup again and taking another cut is not without risk. I might make it worse. I might cut off too much. I might violate that minimum bore height requirement that I mentioned earlier. There's a lot of things that could go wrong trying to make this perfect. So you kind of have to know when to call it, and I'm calling this one here. I think that amount of error I can live with, and we're going to not take any chances on this one. So that's where I'm going to have to leave this video, though. We are out of time. I am actually pleased with the final casting that we got, even knowing there's that little bit of error in it. I can sleep at night. Well, I can feel good about myself. Who sleeps at night anymore, right? Thank you very much for watching. Thanks to my patrons for making all of this possible, and I will see you next time.